Folks, welcome to our first webinar for 2024. My name is Rob Whittle. I'm an aviation safety advisor working out of the Brisbane office with CASA. As per previous webinars, this one will be recorded. I do ask that you please turn off your microphones and cameras to save on bandwidth. Now, along with previous webinars, this webinar will be available on the CASA website under the Pilot Safety Hub Flight Planning section and on the CASA YouTube channel. We will have a short Q&A time following the presentation, during which you'll be able to ask any questions you might have and have them answered with our subject matter expert as well. Joining me today as our subject matter expert and presenting for us is Rowan Kimber, Senior Standards Officer, ARPAS Policy and Regulation, Emerging Technologies, based in the Melbourne office. I sincerely thank Rowan for his time today and the expert knowledge he passes on to us. Welcome, Rowan.
Thanks, Rob. Before I introduce myself, I'd like to respectfully acknowledge the traditional custodians and knowledge holders of the lands we meet today and their continuing connection to land, water and community. I pay respects to elders past, present and emerging, and I would also like to extend that respect to Aboriginal and Torres Strait Islander people who are in attendance today. Hi everyone, welcome. As Rob said, my name is Rowan. I'm part of the ARPAS Policy and Regulation team who are currently navigating the exciting intersection of technology and tradition in Australian aviation. By way of background, throughout my professional journey, I've had the privilege of wearing several hats within the aviation landscape. I've soared through the clouds as a professional crewed aircraft pilot. I've navigated the intricacies of legal frameworks as a lawyer, nurtured the talents of future drone pilots as an instructor, and now I find myself in the fascinating role as a regulator, working to ensure the safe and equitable skies we all share. I thank you for your attendance today. All right, Rob's on mute there. I can take over his bit if he wants, or he can come off. It was either going to be me or Rob that did it today, so thanks, Rob, for took it off me. Go for it.
One of the traps of online, isn't it? Anyway, look, folks, we've partnered with Credly to bring you some digital badges. Now, these badges show your commitment to continuous learning. Some of you may have seen these types of badges on LinkedIn, etc. If you stay for the duration of the webinar, you will receive an email from Credly to claim your badge. Rowan, I'll now hand over to you and I'll put myself back onto mute.
Like you said that word, I was about to start on mute, so we're doing really well this morning. Those badges, they're smart aviators who have got those, and that'll play a key point as we go through today's presentation. Australia's aviation landscape's rapidly evolving. The familiar roar of engines is now joined by a hum of rotors and a buzz of innovation. This merging of traditional and emerging technologies presents both exciting opportunities and significant challenges. The Australian sky is no longer a single-use domain. It's a dynamic ecosystem where crewed and uncrewed aircraft must coexist and cooperate. This evolution brings immense potential, but also requires a framework for safe and equitable operation. As a regulator, I'm not here to clip wings or to stifle progress. I'm here to foster collaboration, build trust, and craft regulations that ensure safe skies, while also empowering traditional and emerging technologies to reach their full potential. Today, I'd like to move forward the dialogue on shared airspace. We'll delve into the intricacies of separation and explore the challenges and opportunities of an expanded aviation ecosystem. I see there are some drone aviators in the room today. While the primary audience for today's presentation is the crewed aviation community, there's something for everyone, and I hope you stick around until the end. To set the stage, let's examine some pertinent facts and figures. The expansion of drones in our skies is undeniable. With over 31,000 commercial drones registered with CASA and conservative estimates suggesting over 1.8 million Australians flying drones, our airspace is certainly abuzz with activity. With such a multitude of aircraft in our skies, encounters between crewed and uncrewed aircraft are inevitable. While properly managed, this offers tremendous opportunities. history has shown us that unregulated encounters can lead to significant disruptions and safety concerns, as evidenced by the incident at Gatwick in 2018. However, amidst these challenges lies immense economic and social benefits. Reports indicate substantial boost to the Australian economy. And disaster response, along with significant other emergency sectors, appear to have significant cost savings. The path forward requires a delicate balance between fostering innovation and ensuring safety. Today, I'll shed light on the diverse types of drone operations in Australia, CASA's efforts to mitigate risks, and how each of us can contribute to safe airspace management. But before we delve into specifics, let's dispel a couple of myths. Firstly, there's no inherent hierarchy granting conventional aircraft greater access to airspace than drones. CASA is committed to equitable airspace for all users. We're required to, as stipulated by the Australian Airspace Policy Statement made by our relevant minister. Secondly, while drones are required to avoid posing hazards to other aircraft, say for certain operations near aerodromes, there's no blanket obligation for them to yield right of way to crewed aircraft. The responsibility for traffic avoidance is a shared one, regardless of the type of aircraft involved. Okay, let's dive into how we stay safe and keep separated. We'll start with the most common operation, those conducted under what is known as the drone safety rules, or the standard operating conditions for the commercial operators. Flyers operating in accordance with this rule set include the vast majority of recreational pilots and lower complexity commercial operators. Most of these flyers do not hold operator certification or pilot licensing. These rules restrict operations to daytime within the pilot's line of sight. Operations are limited to 400 feet above ground level and must not be conducted near aerodromes. There is also a prohibition from operating near non-controlled aerodromes during crewed aircraft movements. For the most part, operations in this category are also limited to drones that weigh less than 2 kilograms. You can think of the standard operating conditions as the drone version of Part 91. Just as Part 91 keeps crewed aircraft operations safe, the standard operating conditions have been instrumental in mitigating drone-related air and ground risks thus far. Now, I think we can manage this. Can I get a show of hands from the pilots in the room, crewed and uncrewed alike, those pilots who are uncomfortable with the risk of collision with these types of low complexity drone operations, the recreational users, the lower commercial operators? I had a feeling I would get a couple of hands. Yeah, there we go. All right. It doesn't surprise me to see that. And let's be honest, it should concern you. At its core, these operating rules limit drones to a mostly atypical airspace, where interaction with crewed aircraft is unlikely. But unlikely, as you know, is very different to impossible. To the question, aviators should always be uncomfortable with the thought of potential mid-air collision and always do whatever's possible to reduce the risk. Let's look at the residual risk of these operations and consider appropriate behaviours for all participants to ensure separation is maintained. We'll start with the limitation to 400 feet AGL, no accident. As most here would be aware, that height limit is designed to work with the crewed aircraft minimum height rule of 500 feet AGL over non-populated areas. That means for most crewed aircraft operating at their minimum legal height, there will be a minimum of 100 feet vertical separation. That's a smaller margin than you may be accustomed to, but given the size of the platforms, sufficient, at least in theory. In practice, like most things in a safety critical environment, it's a little more complicated than that. The legal accuracy of a VFR altimeter is 100 feet. I'm sure you all know that. So a VFR crewed aircraft that is terrain following at 500 feet may well, quite unintentionally, be at 400 feet. Still not together, but close. Add a bit of turbulence though, a spilled coffee, or just being a little rusty, and that could easily be 350 feet. That margin has completely gone. But even then, the chance of a mid-air is exceptionally low. Australia's big. We could fit over 8.5 quadrillion of these size drones simultaneously hovering at 500 feet and still have room for crewed aircraft movements at airports. As I said, the chance of encounter is very low. But CASA does not solely rely on a big sky probability of encounter argument with a bit of vertical separation sprinkled in for contingency as a means to ensure safe skies. As aviators, we're all aware of the concept of risk stacking, as eloquently described by James Reason as the Swiss cheese model, where a catastrophic event could result from a culmination of issues or missteps that were each minor in scope. As regulators, we use a reverse version of this model, stacking mitigators to ensure safety. The requirement for the flyer to operate visual line of sight leverages the now century-old practice of see and avoid. Given the small size of these platforms, the ability to enact this mitigator largely falls to the drone flyer. They're actually in a pretty good position to do this, where crewed aviators are looking for traffic spherically. The focus of the drone flyer is hemispherical. And add to this that the drone flyer has a superpower, the superpower of hear and avoid. The vast majority of potential conflicting traffic can be identified. Once observed, the drone flyer, like all other aviators who identify potential conflict with another aircraft, can take appropriate action. In the now very slim chance of a mid-air collision, the weight limitation of the drone significantly reduces the potential of structural failure upon impact. No doubt, a 2 kilogram drone will leave a significant mark, but the likelihood of impacting a critical system is actually quite low. Summarise. The regulatory system CASA has developed, which has been followed substantially internationally, protects from mid-air collisions by ensuring separation, imposing detection and avoidance requirements, and capping potential impact energy transference. Given the lack of a single significant incident, I think we've got a pretty good system. But as much as you all want to cheer for CASA, and it's okay, I know not every hero wears a cape, some wear a high-vis vest, the safety rate today actually is in no small part to the professionalism of both the drone and the general aviation sectors. You are here today because you are smart aviators. You know that just like fuel in the Bowser or runway behind you, airspace above you is of little help when something goes wrong. Add to that the potential for charted and uncharted obstacles, and that there are potentially another million or so moving drone obstacles. You choose not to operate at 500 feet unless you absolutely have to. And then when you do so with extra vigilance. You turn on your lights to aid visual separation. You fly predictably. You make appropriate radio calls. Just the same, smart drone flyers are aware of the risks of conflict with crewed aircraft, and that increases when operating near airports and at higher altitudes. That's especially so during periods of poor weather conditions. As a precautionary measure, smart drone flyers try to avoid these areas wherever possible. They don't fly high when the weather's not great. They don't fly high near airports. They don't fly near them if they don't have to. They also carry aeronautical radio when operating in these environments, and they turn on strobe lights where feasible. Good aviators are doing these things not because they're trusty regulators telling them to. It's because they understand that aviation safety is everyone's responsibility. To date, the standard operating conditions combined with the professionalism of aviators has served us well. But we are rapidly entering a world where, globally, segregation of airspace will not be the primary tactic in avoiding mid-air collisions. What I really want to talk to you about today are the more complex operations, where drones are routinely operating in the same airspace as crewed. Drones have become incredibly more capable, particularly in the last 5 years. To get the most benefit of the new technology, drone operators need to operate higher and further than permitted under the constraints of the standard operating rules. Unlike crewed aviation, there is no expanded rule set for drone operations in traditionally crewed airspace. Technological barriers and the innate differences in platform design have, to date, prevented drones from neatly fitting into the Part 91 operating system. From a regulatory perspective, incorporating the new technology neatly in Australian airspace has significant issues, and CASA has been progressively chipping away at it to ensure Australia is appropriately positioned to facilitate complex operations in shared airspace in a safe and equitable manner. CASA's current approach to safe enablement is largely based on a case-by-case assessment, with CASA imposing operational conditions required for the specific operations. You can think of this as a tailored Part 91 rule set for each concept of operations. Thus far, this is working really well, and both CASA and industry are figuring out where the risks lie and how to mitigate them. For example, we've found that operations above 400 feet pose a negligible increase in risk when conducted in airspace that is visible to a trained and competent operator. While sighting the drone becomes impossible as height increases, the drone flyer's view and the sound of nearby aircraft is less likely to be obstructed by terrain, and situational awareness of crew traffic is actually generally improved. This concept extends to operations where the drone flyer does not personally have visibility of the airspace and instead relies on a dedicated airspace observer who uses a sort of human radar system to identify traffic and pass the information to the remote pilot. That remote pilot then creates an airspace picture and determines the appropriate action to be taken. But as complexity of operations increase further, the human radar system becomes impractical, and there's a greater reliance put on technology and planning. For these operations, where the drone is operated outside of the site of the drone crew, CASA usually bases approvals on a risk methodology called Sora, created by the Joint Authorities on Rulemaking for Unmanned Systems, JARIS, a body made up of 63 national aviation authorities, as well as EASA and Eurocontrol. And as you can see by the map there, Australia is a member state of JARIS. We've actually contributed heavily to the methodology to ensure that it's fit for purpose in Australia. In brief, the Sora is a largely mathematical model that considers the probability of encounter with crewed aircraft, the density of population on the ground, and the probability of failure of a drone, and then imposes a series of mitigators that must be implemented by the operator in order to operate in that location. CASA has worked with internal and external airspace modelling experts to predict crewed movements as best as possible given the present limitation of ADS-B data from VFR aircraft intent. The Sora model is used as a basis for essentially all complex and semi-complex drone operations in Europe. As part of CASA's readiness program for complex drone operations in Australia, we've been testing the local application of the model and progressively increasing the complexity of drone operations we approve. Continued positive safety outcomes has provided a level of comfort with the model, with it now being commonplace for CASA to approve beyond visual line of sight operations in unsegregated airspace. From a mid-air perspective, why we're all here today, the Sora encourages operators to operate in volumes with low probability of encounter, either intrinsically or through the use of strategic mitigators. Strategic mitigators refer to the measures taken by the operator before the commencement of flight to reduce the rate of encounter with crewed aircraft. These measures include things like restricting operations to specific times of the day, working with local operators to create pre-arranged separation, or choosing to fly at a different height to avoid areas of high concentrations of crew traffic. Once strategic mitigators are implemented, there is a review of the residual traffic density to determine if an unacceptable probability of encounter remains, and if so, tactical mitigation requirements are imposed. For those numbers people in the room, the rate of encounter that triggers additional requirements is anything more than one encounter with a crewed aircraft per 1 million flight hours. It's a pretty big number. The tactical mitigators refer to actions taken after takeoff and are, in simple terms, detect and avoid criteria. The level of detection and avoidance measures taken depend on the density of residual traffic. For instance, if a drone is operating beyond visual line of sight at Sydney Airport, it should be able to detect all traffic in the volume and should be able to avoid collisions in the same manner as a crewed aircraft would. Conversely, if a drone is being operated in a low traffic area, think 1,000 feet AGL in a remote part of Western Australia, it's sufficient to detect only about half of the traffic in the volume. And I know that sounds like a low number, but when combined with the statistical probability of there being any aircraft in the volume, and in light of the known limitations in visual see and avoid, the model predicts a mid-air collision rate far safer than provided by conventional aviation. For drones operating in this way, it's all about technology, primarily that technology used to detect aircraft. Most complex drone operators in Australia use a combination of aeronautical radio and ADS-B in to build their airspace picture and coordinate with conflicting traffic. Obviously, we all know this, ADS-B is the best tool available and provides visibility of essentially all equipped aircraft in the volume. For this reason, many of the newer drones available in Australia, even the small recreational drones, come pre-equipped with ADS-B receivers on the drone, and that provides the best possible ADS-B reception. Aeronautical radio has significant limitations, being only as good as the person on the other end and suffering from other technological limitations, atmospheric and the like. Regardless, radio remains a valuable tool in traffic deconfliction. Following the mitigation stacking model, there's another line of defence though, the humble NOTAM. Essentially, all drone operations in Australia conducted above 400 feet AGL require promulgation of a NOTAM to let other airspace users know that there's a greater potential for conflict in a particular area. The NOTAM will provide the frequency the drone operator is monitoring and a contact phone number. A simple phone call to confirm the specifics of operations or a radio call prior to entering an area with known traffic will go a long way to ensuring separation, as too would be avoiding the area if there are other viable tracking options. For IFR pilots, traffic avoidance without see and avoid is commonplace. For VFR pilots, this may be slightly different to what you're used to. In truth though, VFR or IFR, for a good aviator, there really isn't any difference to crude traffic avoidance than it is with drone to crude. A good aviator checks NOTAMs. They actively use their aeronautical radio to tell other airspace users where they are and to build a mental model of other traffic. The best aviators utilise ADS-B out and in to see and be seen electronically. So what's next for drone and crewed aircraft separation? Well, globally, there's a push to normalise drone operations in the airspace system. This is one of the key issues CASA's emerging technologies and regulatory change branch, together with the RPAS Inspectorate, are currently grappling with. We're pretty confident that the current approach of an approval per operation is unsustainable, and we've learned a lot about safe integration. While there's still a lot of ground to cover, it's becoming apparent that there will be a convergence of rule sets and operating systems for crewed aviation and large segments of the drone sector. What that will ultimately look like, it's far too early to tell. There's still significant technological advancements and operational knowledge required. What I can say though, with pretty high confidence, is that electronic conspicuity will have an ever-increasing role to play in keeping skies safe globally. We are in a world where visual conspicuity is not always available and not always adequate. The sad occurrences of mid-air collisions in recent times, the tragic loss of life, are grim reminders of the limitations of see and avoid. The ability to see and be seen by all airspace users at all times and have technology assist us with traffic avoidance is simply too great a benefit to overlook. To that end, I remind the crewed aviators in the webinar that the Commonwealth Government's ADS-B grant scheme is still open. Grants of up to $5,000 are available to Australian registered aircraft to go towards ADS-B fitment. I understand that this is not the complete cost, but we all have an obligation to keep separated. And it's a small price compared to the potential cost of a collision. In many ways, the future is already here, and we really do need to lean into technology that can make our lives and our skies safer. To sum up, Australian airspace is a shared national resource. Drones are here to stay, and the complexity, size, quantity and use is likely to continue to increase steadily. Separation is everyone's responsibility. I've added another little one there. ADS-B is probably better than sliced bread. I think that's probably the case. To the drone pilots in the room, you can play your part by operating low wherever possible and ensuring compliance with the height and location rules. Maintain good situational awareness at all times. Enhance when operating in the vicinity of aerodromes or on poor weather days. Sound is as important as sight. Keep an ear out for traffic. Be courteous to other airspace users, even when you have right of way. Keep your eyes up. Be mindful that the person paying for the fuel and the maintenance on the crewed aircraft, for the most part, has an hourly rate far higher than the drone. It's just polite to avoid an aircraft having to take extra track miles where possible. Carry an aeronautical receiver. Even better, get an aeronautical radio license if you don't already have one and make appropriate broadcast. Read NOTAMs. Sometimes it's better just to not operate at a particular location on a particular day. To the crewed aviators, use your radio. Be predictable. Avoid flying low where you can. Obviously, sometimes we need to stay safe. Lights on where possible, and pretty please, fit and use ADS-B out. And it. This conversation doesn't end with the last slide. Let's use this platform we have to foster dialogue. Let's exchange ideas and address concerns. What are your thoughts about sharing the skies with drones? What steps can we take to build trust and collaboration between general aviation pilots, remote pilots, and the regulator? How can we harness the full potential of both technologies to make Australian aviation a global leader in safety, innovation, and efficiency? By embracing collaboration, prioritising safety, and fostering open communication, we can write a new chapter in the story of Australian aviation, one where the future soars brighter than ever before. Remember, the air is vast, and together we can make it a space where pilots of all stripes can take off, explore, and reach new heights. Thank you.
Rowan, thank you very much for that. Folks, thank you very much for joining us online for this presentation. And again, thanks to Rowan for his valuable presentation that he's given us today. I trust that everyone has learned something new from today's presentation. I have put quite a bit of links into the chat for everyone to use, and certainly a copy across. Don't forget though, the RPAS criteria are found in the plain English guides on the CASA website. CASA part, or CASR, the Civil Aviation Safety Regulations 1998, Part 101, and also the accompanying Manual of Standards. Now, question time. Rowan, there's one here that was asked by Peter. He got in early before you were talking about the ADS-B, etc. Peter, I'll throw to you. Was the information given after you asked your question about Sky Echo and ADS-B, did that answer your question, or would you like some further information in reference to your question with ADS-B on drones?
I can probably talk generally. I didn't see the question there, Robin. I'll see if someone comes back with it, but I can probably talk generally on ADS-B. Look, obviously, I mentioned ADS-B a lot during that presentation. It is one of the biggest problems that we are trying to grapple with at the moment. We build airspace models to try and enable some of these operations to ensure that we can keep separation. A lot of what we use to underpin our models is understanding of what the traffic density actually is in an area. And so we make approvals or don't make approvals based on some assumptions. And I should say, I forgot to mention this earlier, one of those assumptions that we do when we make an approval in a particular area is that crewed aircraft are equipped with radios and use their radios in much of Australia. So that minimum level of professionalism when it comes to radio is there, which by 2024, obviously we all expect that to be the case. But to the ADS-B point, more data we've got, the more we can build better models, the more we can make sure that RPAS that are operating in areas of higher traffic are doing so with the appropriate mitigators. And also where there's areas of less traffic, then we can open up some of those areas for drones. And a lot of the RPAS sector is actually looking for that, particularly our research and development areas where they really want to go away from the crewed traffic. We just don't know exactly where that is. So the more people can equip, the more they can provide that data. And rest assured, when we look at our data, it's all de-identified. CASA really doesn't want to know where you are all the time. Your privacy is protected. It's not about that. It's about us understanding what's in a particular area, what type of traffic's in the area, the volume that's in the area, so we can build the best models.
Yep. I don't know if you can hear me now.
Yep.
Sure can, Peter. Yep.
Excellent. First, a side point, it would have been great if the ADS-B subsidy was available to the thousands of hang glider and paraglider pilots that and powered paraglider pilots that are flying, within uncontrolled airspace, but doing quite significant flights. The specific question, things like Sky Echo, are they visible to ATC all the time, or other aircraft?
So I'm actually going to leave that question to an airspace expert, so we might put that on notice. It's certainly that technology is visible to the technology that we're using in drones to be able to detect ADS-B. And so those smaller ADS-B units, absolutely, they're detectable. To your point, and you caught me out on something, Peter, I didn't include anywhere in the presentation about the risk of sport aviation, in particular hang gliders, paragliders, those things that routinely operate below 500 feet. They are a continuing concern for how we build our models, and the more data we can get there on them, the better. And so your comment's been heard. We're not the area that does it, but we're certainly continuing to escalate that. Anyone that can have ADS-B, the better we are for it. So thanks so much for that comment.
It's probably worthwhile just to emphasise that hang gliders, paragliders, and powered versions of those also do quite significant flights above 5,000 feet as well.
Yeah.
And we can feel kind of vulnerable up there.
And understandable. Yeah, absolutely. I mean, people that are in the airspace system, I was a crewed aircraft pilot for many, many years professionally, and we tend to assume that we're the only ones there and that everyone's flying hemispherical and everyone's doing it in the way that you would expect a commercial pilot to. But when you're flying around in the sort of platforms you're talking about, that's just not how it works. And so I think that's it's a really important reminder that we need to feed that into our models as a regulator and at Air Services, but also all of the pilots in the room need to build that into their mental models. So thanks so much for that, Peter. And certainly that comment will be taken, and I encourage anyone, wherever we can fit ADS-B, regardless of the aircraft type, then, if it looks like an ankle monitor, but it keeps you safe, then, even if you're in a parachute, wear it. Whatever we can do to get the data and stay safe, I think it's really important. So thanks, Peter.
Thank you.
Thank you, Peter. There was a question/comment regarding ADS-B out, whether or not there was a risk of thousands of drones that are fitted. Those devices with those frequencies reach saturation and ineffectiveness. We'll certainly take that one as well. Look, one for the airspace, but yes,
I can mention that. Yeah, look, I'll quickly talk to that. It was in an earlier draft of this presentation, and I took it out. But you can't get anything by the people in this room, which is great. They're the smart aviators. Our current system really just simply can't handle the level of traffic that we would have if all of the RPAS turn their ADS-B on. And so we're being pretty selective. While they're working through these problems, we are being pretty selective. Rest assured, though, if a drone operation is conducting operations in areas of higher traffic density, it almost certainly will be running ADS-B. And so you'll be able to check that traffic. So we're selectively doing it under 500 feet where the chance of encounter is exceptionally low. It's not so important. When we get above that, then obviously it becomes more important. So obviously the drone team needs to do just as much as the crewed aviation team to make sure that we can be seen. So good point, something that we're working on, but those that need it have it and it's turned on.
I have a question from Nicola. Currently, segregated airspace is the approach, but not a long-term solution. What do you think is the next step moving towards integrated, crewed and uncrewed airspace use?
Really, another good question.
A good one.
Really good questions today, Rob. You hadn't warned me for this. So, look, we've been thinking about this a lot. There's really three options when it comes to the future of airspace. It is either stay segregated, in its current way. It is to create volumes of airspace that favour uncrewed operations, so your UTM style. Some areas around the world are looking at this concept of U-class airspace. We are not currently looking at that, but that's certainly one of the things that is being looked at internationally. And the other one is to move towards finding a way that you can have a single rule set for all operations. And I think ultimately it's going to be a mix of the approaches. There will always be some level of unsegregated because we have these areas of Australia where there really isn't much in the way of crewed air traffic. And it's really not safe for crewed air traffic to be operating there anyway. And I know as a pilot, it's not a really, as fun as it might be sometimes and as good as it looks outside the window, it's really not smart to kick around at low level. And so we have huge areas where it's just a smart bit of airspace to put the drone operations. And it may well be that if there ever is U-class airspace globally, and that comes from ICAO, then that would be reserved for those sort of areas where we're not expecting crew traffic anyway. So it's more about regulating the uncrewed. As far as integration, my prediction, and this is just my prediction at this stage, is that we will get to a point where we will be able to have more and more of the RPAS platforms be able to fit within the existing system because of better detect and avoid. I mean, let's be honest. If every aircraft in Australia, if every pilot went out there and made sure they were running ADS-B, before they went and hired an aircraft, they checked, does that aircraft have ADS-B? When they've got their own aircraft to put ADS-B, there really would be not that much that would stop our drone operations fitting into Part 91 at some stage. So I would say that at some stage that's where it's headed. But the steps we need to do before then is understand the risk, but also make sure we can see and be seen.
Rowan, just taking it probably a little bit of a step further, and I note Nicola's put another question in the chat as well. But talking about frequency congestion, so you have a crewed aircraft, ADS-B, etc., going out. You may have drones with the ADS-B, etc., going out, but mixed into all of that, you've also got the frequency bandwidth controlling the drones. Has there been any, in your experience, has there been any thought of a consultation process at all regarding bandwidths?
Yeah, look, we have. It's an ACMA issue, and I'm not avoiding the question because it's a valid question. And I'm really quickly typing something in the background to confirm that what I say is absolutely accurate, and it is. 1090 megahertz is the frequency that we're running on for our ADS-B system. Most of the command and control in drone operations are not running near that frequency, and so we're running 2.4, 5.8 gigahertz. There is some running around the 900. ACMA is the one who deals with frequency congestion at this stage. We're doing pretty well with it. There are other frequency bands that are available if we move to the licensing. So one of the things that's likely to happen, and in fact the Sora requires, that as we get to more complicated risk scores, we start to look at having dedicated frequencies for those particular operations, having licensed frequencies through ACMA. So there will continue to be noise from the smaller aircraft. Most likely they're going to continue to be operating around the 2.4, 5.8 gigahertz. The biggest impact you're likely to have with that is issues with Bluetooth and issues with Wi-Fi, that you've got congestions on that band. As far as impacting the aviation ecosystem, it's pretty unlikely that we're going to see any issues, certainly from any of the smaller aircraft. And the bigger aircraft, ACMA's working pretty hard to deal with that.
Beauty, thank you very much. An important thing that we haven't mentioned is AvSafety for drone operators needing to engage with stakeholders. How would they go about accessing the AvSafety website, especially when you're talking about the density of the airspace that they might be flying in or want to do operations in?
I'm going to take that one on notice. I can talk to what we're currently doing for stakeholder engagement, and our current system is a little bit more localized than that. We work really hard with doing local traffic studies. So all BVLOS operations, for instance, start with the concept of a traffic study and goes right back to phone calls, walking around, talking to the local operators to find out what the actual traffic is there, obviously looking at ADS-B data. AvSafety is really important. It's a really good forum. As far as access to that, I think we'll take that on notice if that's all right, Rob.
Yeah, definitely. No, that's good. Thanks, Rowan. Another good question for you. Where does the greatest risk in the RPAS industry come from? Is that from the trained, certified RPAS operations, or from the recreational pilots flying the same drones in the same locations?
You know, it's an exceptionally good question because we haven't had any accidents. Like, there hasn't been a mid-air collision, and so it's really hard to get the data to see what's going on. I think that if you were to go and get untrained operators and put them in commingled airspace, we'd see something very different. I mean, we have a licensing and certification system for our operators intentionally, and it works very well. And it's the backbone of being able to do things like above 400-foot operations and BVLOS operations. And in all of that, it's underpinned by a really high level of training. And for our BVLOS work, our beyond visual line of sight, we've even got a tailored exam for our drone pilots now that they have to do to fly beyond visual line of sight. And so we put a lot of effort into that, and it seems to be working. I think it's a little bit difficult to say exactly where the risks come from. It's all about where you are at a particular time, but it's relatively well managed.
Cool. All right, scrolling through some of the questions here. With the increase in drone flyways, where drones are flying away without obviously the operator being in control, what is, I guess, CASA's response to monitor the increase, perhaps, of these actual flyaways?
Yeah. Okay. Interesting point from a drone operator. So I worked for several years in a drone consulting firm doing drone training and operational work. Flyways, the incidence of flyways have actually decreased significantly over the last 5 years. So our technology is getting much, much better. One of the things we do, though, is for areas where you're operating a drone near crewed aircraft, we have contingency requirements. So there is a containment area that has to be put on. So Sora requires this, a whole bunch of containment requirements. And one of the things we look at for those, the most risky, is the ability to do independent flight termination systems. And so if we've got an aircraft in a particularly high risk environment where the chance of where a flyaway would have a higher chance of impacting a crewed aircraft, then that aircraft will have a higher reliability on their flight termination system. So, and actually the model is built like that. So for the Sora model, for those who haven't seen it, it's built with a series of volumes, and depending on where you are in your contingency or when you hit the edge of your contingency volume, it's a compulsory in-flight shutdown. And so for our smaller aircraft, that's built on the technology that comes with the aircraft. But as we get to the more risky areas, then we look at what's the independency of flight termination system. Is it you're running a completely different link, a completely different frequency to make sure that no matter what, it won't run into that flyaway. When it comes to things like drone light shows, most of those platforms are running a double geofence system. So they'll have a system that if the aircraft does enter a flyaway state, a separate system on board the aircraft will then activate a flight termination, so that we've got multiple systems running there to avoid it. So look, risk of a flyaway, obviously it's there. That's why we've got all our models. That's why we look at all of this. But realistically, in 2024, I don't think it's anything we need to be particularly concerned about. If we run with our models and we implement the strategies we've got, I think we're running pretty well.
Yeah, Paul, thank you very much. Look, some really good questions coming through there. Really good to see the thought processes going on and obviously the questions of that coming out. Unfortunately, though, we're going to have to wrap it up there. This recording will be available shortly on the CASA Pilot Safety Hub under the topic of flight planning. Our next webinar will be in February with the topic of flight reviews. So keep an eye out for when that one is advertised, and I hope we can see you all present for that one as well. Now, don't forget to check your emails for one from Credly and log on to the site to receive your badge. Thank you very much, everyone, for attending. I hope everyone has got something out of it, and goodbye for now.